this class we will learn an essential programming concept for app developers. More precisely, how to decode JSON data using Swift Codable. We are going to parse JSON data and populate this information about each African animal into a page tab view. As you can see in this preview video, we will make great progress in developing this application by the end of this lecture. But before we start, I would like to ask you to bear with me from start till the end of this class. Today, we will cover a pretty important topic, and that's why this lecture is a bit longer. Nevertheless, it's still a practical tutorial, but this time we will pause once or twice while I am going to provide you more explanation about some programming concepts than usual. We have a lot to do, so without further ado, let's launch Xcode and start coding. Shall we? Cover image. First, we are going to prototype the whole layout, then we will cover the JSON parsing. As I said before in the previous tutorial, we collect all the smaller or reusable views in their dedicated folder. Having said that, let's create a new group on the Project Navigator panel. Give it the name View. After that, as usual, let's create a new SwiftUI view for the cover images. Name it to Cover Image View. Now save it into the View folder as I do. Nice. After that, I am going to create a new comment mark with a horizontal divider for each main code block in this file. Follow me and enter. Mark, Properties, Mark, Body, Mark, Preview. This special comment type is used to divide functionality into meaningful and easy to navigate sections. You can reach these code sections on the toolbar or in the minimap with ease. In the later videos, I will not waste any time to mention it once again, but I will use these comment marks regularly. Now let's add a layout modifier to the preview window. Shall we? Enter. Preview layout. Fixed. Width 400. Height 300. Super. We can zoom up this window in the canvas if we need to. After that, replace the placeholder text view with a new static image for prototyping purposes. Enter. Image. Cover. Lion. Resizable. Scaled to fill. Alright, so far, so good. Now let's embed this image into a new tab view. Enter. Tab view. New comment, end of tabs. Now move up the image inside this view. Then wait for a sec and see the result in the preview. Of course, this is not exactly what we want. To fix it, let's add this modifier to the tab view. Tab view style, page tab view style. It's much better now. Now we need to repeat this image. The easiest way to do that is to Command+click on the image name and select the repeat option from the contextual menu as I do. Then enter. For each, new comment, end of, loop. Great job! As you can notice, little dots showed up as an indicators of the page tab view on the bottom part of the image. The beauty of developing in SwiftUI that we can instantly see what's happening using the live preview. Now let's start this live preview by clicking on its button on the toolbar of this preview window. When we start it, you can notice that it launches a built-in simulator and the page indicators are off the image boundaries, but it's not a big deal in my opinion. Just swipe to right to use the functionality of this new UI element. See? It works without any glitches. Of course, this is only the same lion repeated 5 times in this page tab view. JSON basics. And With finishing up the layout design, we can finally talk about JSON and learn how to parse then populate its data into this view programmatically with Swift's Codable protocol. Does it sound interesting? I hope so. So, what is JSON? Well, JSON stands for JavaScript Object Notation. It's a compact, easily readable file format for data structuring. In general, it's primarily used to transmit data between a server and an application using some kind of application user interface, as known as API. Not only that, but we can also use it to store and parse JSON data directly inside a local app bundle. You know, it's a text-based format representing different kinds of information. But you should also know about it that a JSON file consists of key-value pairs and it uses brackets, parentheses, and colons for separating the elements from each other. A JSON data structure can represent different types such as string, number, including integer and double, then Boolean, array, dictionary, and even optional. As app developers, what's fortunate for us is that each of these JSON types can map to a corresponding Swift type. The only exception is the date type, but we can always convert dates into numeric or string representation of this data. Alright, before we start learning how to parse a JSON file, first we will take a quick look at this simple JSON structure. This one contains some key value pairs where the values are basic types like a string or a number. There is also a value representing an array of strings in this simple example. To use any JSON file, first we need to create a corresponding data model in Swift. With this data model, we can easily decode any data using Swift's built-in decoding and encoding functionality. For that, we can run a JSON decoder alongside the Codable API. It's worth to mention that this Codable API will do the hard part of the work to generate the output that we will need to use in SwiftUI later on. By the way, this Codable is a type alias, which consists of the encodable and the decodable protocols. I am pretty confident that by finishing this Africa project, you will get familiar with all the basics of how to use JSON in SwiftUI. Dealing with JSON data is such a fundamental part of app development, therefore we will deep dive into this topic in the upcoming sections of the course. Now it's time to decode the first JSON file in this Africa project. Data model. Now navigate to the project navigator and unfold the data group to see all JSON files added to this project. For a practical standpoint, select the covers.json file and let's have a short look at the data structure of this JSON. As you can notice, it's a basic and easily digestible data file. Each object has only two elements. The first one is the ID key, which is a type of number. The second one is the name key, which is a string type. Now we need to create a new Swift model file that is matching with this data structure. I would highly recommend you to click on the Add Editor to Write button at the top right corner of the toolbar as I show you. With this, we can see the JSON file on the left side of the editor while working on the data model on the right side of it. I tend to use this functionality quite frequently for this situation because I find it quite practical even on my tiny screen. Now, of course, we need to create a new Swift file for this model. To do that, first select the Africa project folder, then let's create a new group for all model files. Name it to model. Then let's create the actual Swift file as I show you. Select the empty Swift file template on this pop-up window and give it the name Cover Image Model. Then click on the Create button. Awesome! Let's get down to business. First, let's create a new struct. Enter. Struct cover image. Let ID int. Let name string. Great! The ID and the name properties inside this structure are matching to the keys of the JSON files, and that's exactly our main goal. Now, to successfully parse and populate the data, we need to add for this struct two important protocols to it, namely Codable and Identifiable protocols. So let's do it. Enter. Codable. Identifiable. See? This cover image model is ready to use to decode the JSON data. Alright, I think it's pretty easy to remember these ID and name properties, so we don't need to keep open either this model file or the JSON data file. Just close them as I do. Decoding. There are many ways to decode a JSON file. An easy, lazy way, or a proper but much longer solution. I am going to show you the better one. But before we start coding, it's always a good practice to go through the logical steps that we need to make to solve a programming goal. And we can do it right now thanks to pseudocode. What is pseudocode, you might ask? Basically, in computer science, a pseudocode is a plain language description of the steps in an algorithm or other system. That's it. Now let me define these necessary steps that we need to make to decode a local JSON file, alright? But before to do that, let me clarify the main goal that we want to achieve. Goals. We want to decode a local JSON data, then use this data to populate a SwiftUI view. Also, we want to create an algorithm that we can reuse not only one time, but many times over and over again within our project. Moreover, our main objective is to decode not only one specific JSON file, but multiple JSON files with the different data structures. To simplify this complex goal, first we are going to accomplish the first and the second goals in this particular lecture. But don't worry, in the next class we will cover the third goal as well. Steps. Alright, here goes my pseudocode in plain English. The algorithm must safely do these following tasks. First, locate the JSON file in the app bundle. Second, create a property for the data. Third, create a JSON decoder. Fourth, decode the data and collect the information with a new property. Fifth, return the ready-to-use data. And this is how I can break down this complex goal into many logical baby steps. We can use this method to create a new function somewhere in the SwiftUI file that we can call when we need to. However, we can do this in a much efficient way if we use this function as an extension. And that's exactly what we are going to do. Okay, but what kind of extension we are talking about? Do you see the first step on this list? To locate a file in iOS app development, we need to use the bundle. You know, Apple uses bundles in iOS and macOS to present apps, frameworks, plugins, executable codes, or related resources such as images, sounds, videos, or other files. In our case, these are the local JSON files. That said, we are going to extend the bundle functionality with our custom JSON decoder extension. Are you interested to learn how to do it? I know you are, so let's do it. Bundle extension. First thing first, let's jump back to Xcode and create a new group for the extension. Give it the name extension. After that, let's create a new Swift file as usual. Name it to Codable Bundle Extension and save it to the new group. Alright, now let's create a new bundle extension. Enter the following code with a new decoder function inside it. Extension bundle. func decode underscore file string return array of cover image. As you may notice, this decoder function has only one parameter. We decided to call it simple file, which is a string type. By the way, with the use of this underscore, we don't have to enter the name of the parameter each time when we call the function. We must only enter the actual JSON file name without the parameter's name, but you will see how this works later on anyway. So, we use this file parameter to tell the decoder which JSON file to parse and decode. In this case, this is an array of cover images. I hope that everything is clear so far. Now, before continue coding in an ad hoc way, we can utilize the pseudocode that you are already familiar with it. Let's write down the main steps of this algorithm as new comments. The first step. New comment number 1. Locate the JSON file. The second step. New comment number 2. Create a property for the data. The third step. New comment number 3. Create a decoder. The fourth step. New comment number 4. Create a property for the decoded data. The fifth step. New comment number 5. Return the ready-to-use data. See, this is the blueprint or decoder's algorithm. Now let's implement these instructions written down in plain English to real code, shall we? Enter the following code. Guard let URL equals self URL for resource file with extension nil. Else fatal error failed to locate file in bundle. As you can see, we are using Swift's guard statement when we create the URL constant to handle the possible errors. So, if we misspell the JSON file name or it doesn't exist in the app bundle, then our running project will crash with a warning fatal error message for us. In that case, we will always know what we screwed up in our code. Of course, we shouldn't force our app to crash in a production-ready app, and there are many ways to handle each scenarios. Oh boy! You know, proper error handling is a colossal topic in app development. But for the sake of completeness, I will introduce it incrementally over the upcoming projects. Alright, now back to the algorithm coding. Now enter the following code. Guard let data equals try question mark data contents of URL. Else fatal error failed to load file from bundle. With this computed property, we try to put the JSON data as a data type itself into this new constant. The reason behind that, we couldn't know whether the JSON file is corrupt or not. If it's broken and we can't use it as data, then our app will crash again, but this time with a different error message, so we will be informed about what went wrong. Okay, let's continue with the third step, shall we? Enter. Let decoder equals JSON decoder. It's quite self-explanatory in my opinion. We have just created a new constant with a JSON decoder method that we are going to run in the next step. Next, enter. Guard let loaded equals try question mark decoder decode array of cover image dot self from data. Else fatal error failed to decode file from bundle. Now I can tell you that this is the main section of this algorithm and worth to analyze it a little. First, we created a constant that will hold the decoded JSON data. But to do that safely, the JSON decoder method first needs to try this decoding operation. The JSON decoder needs to know two important pieces of information to do that. First, the decoder requests information about the type that we need to decode. In this specific case, it is an array of cover images. Pay attention to the fact that this type must conform to the decodable protocol, otherwise it will not work at all. The next information is the source data. You can see this is our JSON file in our app bundle referred by its URL. In case both the data type aka data model and the data source are valid, then this decoder method using the Codable API will decode the raw JSON data and put the result into this new property for us. We have only one last step to finish up the JSON decoder extension. What the compiler was upset about during this whole time is a missing return value in the function. Let's fix it, shall we? Enter. Return loaded. Fantastic! The error is gone and we finished up with this well-designed JSON decoder extension as well. The final result of this function will be a serialized array of cover images that we can use in SwiftUI file anywhere and anytime. What do you think about it? By the end of this whole section, you will see how valuable it was to create this handy extension. Implementation. Now, without further ado, let's use this extension to populate the page tab view with real data. First, open the cover image view file as I do. Then, let's create a new property for the actual cover images. Enter the following code. Let cover images, array of cover image, equals bundle main decode covers.json. As you can see, it's pretty easy to use our bundle extension and decode a given JSON file. All we need to do is to call the decode function inside the bundle extension. This will decode the covers.json file and store the decoded array of cover images into this new property for further use. Now navigate to the for each loop and replace the placeholder with this property as I show you. Enter. For each cover images. And finally, replace the hard-coded image name with our dynamic property. Enter. Image, item, name. The best way to check our code whether it works or doesn't is to start the live preview and test the page tab user interface. So let's do it. And here it goes. We can swipe to right, then back to left and see how the cover images are populated into the page tab view. Wonderful. Final touches. Now it's time to embed this cover image view into the content view. Open the content view file and delete the placeholder text. After that, enter the following code. Navigation view. New comment end of navigation. Now let's create a new list inside this navigation view. List. New comment end of list. And finally, embed the cover image view inside this list. Enter. Cover image view. Oops! The page tab view is so tiny. Let's fix it with a new frame modifier, shall we? Frame height 300. It's much better now, but far away from perfect. As you can see, there is a default padding around the tab view. But hey, we can easily override this default behavior of the list view by adding a modifier to the specific list row. Enter. list row in sets, edge in sets, top 0, leading 0, bottom 0, trailing 0 as well. This modifier gets rid of the padding and the cover images expands its size horizontally to the left and right edges of the screen. Finally, add a new navbar title modifier to the list view. Navigation bar title Africa. Display mode large. Splendid. Just one more thing before we call the day and the final test. It turned out that I told you something wrong when we created the cover image view, and now we need to fix my mistake. Please open the cover image view and navigate to the modifiers of the image. There we need to exchange the scaled to fit modifier to scaled to fill modifier as I show you. By the way, this is the right method to make the image to touch the horizontal edges when we are using a fixed height frame. Testing. Now we are going to finish up this long lecture with testing the application. Are you ready for it? Then let's build and run the Africa app in the Xcode simulator. After the initial launch period, we can swipe to right and left the cover images in the Page tab. How cool is that? I really hope that you have a better idea of how to parse, decode, and populate data from a JSON file. In the next lesson, we will expand the functionality of this JSON decoder and make it capable to decode not only one type of file but other JSON files as well. From that, nothing can stop you to decode any JSON file as an app developer. Having said that, see you at the next class.